Welcome back. We are going to do level 2 of this Cracking the Cryptic 500k special. This one, Elevensies, we'll go with new. Let me just explain the rules once again. Classic, you should know it. Killer. So the cells in each cage must sum up to the number in the top left corner of the cage, if given, and numbers cannot be repeated inside a cage. So what this means is that, let's take this cage here, for example. The two numbers inside this have to sum to 11. So let's say it could be a 9 and a 2, or it could be a 3 and an 8, or whatever sums up to 11. The second part, numbers cannot be repeated inside the cage. Really, I think it's just these big cages here. So we have a 2 here. Normally you would be able to place a 2 in this bottom right hand corner, but given that numbers cannot be repeated inside this cage, a 2 cannot go there. That's pretty self-explanatory. German whispers. Adjacent digits along a green line must differ by at least 5. Let's just take this big green line here, for example. Whatever number we'll start with, let's start with 4. This digit here has to be differ by at least 5. Can be more, but at least 5 will take us to 9. Let's go at least 5, maybe down to 1. That is greater than 5, up to 6. That's not better than 6 actually. Let's go to 8. 8 will go down to 2, and then up to 7. So all these numbers differ by at least 5 from their adjacent pairings. So let's just get rid of those. Yeah, and I've already noticed a few things while just giving the demonstration, but let's get cracking. One of the few things was this box here, obviously. 4 11s are 44, and the numbers 1 through 9 sum up to 45. 45 minus 44 is 1. Jeez, smart. The other thing is, remember, rule about these. There's a few rules about these I have to remember. First one has to do with the number 5. Now the 5 cannot go on a green line, because if it has to differ by at least 5, we'd have to place a 0 or a 10 next to it. Obviously those numbers don't exist on a Cracking the Cryptic board. The other interesting rule is that, so we'll say that, let's say this number is a 6. This next number here has to be a low number, which we'll consider. This number is 7. This next number has to be a low number, which is, we'll consider 1 through 4, because 5 is neutral in this. And then this next number has to be high, this next number has to be low, this next number has to be high, and this next number has to be low. Which means we can kind of get a general idea of how these go by shading the boxes certain colours. So we know all these pink ones are going to be the same parity, so either high or low, and that's the same over here. But we do not know if these, we don't know if these correspond with each other, whether this and this are the same, or this and this are the same. So where to next? 5s across here. Can't go on the bottom 2 of 5, obviously can't go on the whisper. 5 goes up there. The next thing I want to notice is, what is this? 4. Oh yeah, 4s are interesting because a 4 cannot go in the middle of a whisper, as 4 only has one number it can be next to, which is a 9, because then no other number can go next. So the 4 can't go there, and same with the 6 as well. 6 has got the 1. We've got a 1 here, which means we cannot have a 6 on this whisper. Cannot have a 6 on this whisper, which means this now becomes a 5-6 pair. Okay, that does think we're going to use the same logic on this other whisper now. So this 6 obviously means the 6 can't go down here. Now the only place the 6 can go in this box is on a whisper. The other interesting thing is, obviously we know the 6 can't go in the middle of a whisper, so it has to go on one of the ends. Making one of the ends the ends have to be high. They have to be a high number. Because a 6 can't go in the middle, and we know a 6 is a high number, and 6 has to fit in this box. Yeah, that works. Okay, so let's just get rid of these colours. Actually start colour coding this for good. So we know 6 has to go on the ends, but we still know that the middle, but we know the middle will have to be the other 2. We'll use red for high, which is 6, 7, 8, 9, blue for low, 1, 2, 3, 4. And we'll do this because temperature, red's hot usually, blue's cold. Except if you're talking about flames, but I don't want to get into that at the moment. So there we go, we know red's high, blue's low. Okay, where to next? Well, we know the 6 has to go on one of these 2, but that doesn't really help us. But you know it does, because the 6 then has to be next to a 1, and we can't place a 1 in this low. So that has to be 6, and that has to be a 1. Obviously this can be any of the other 3 high numbers now. That's a low. The other thing. I've got it. You should break it a little bit now. The 11. The 11 pair has to be a 5, 6, 7, 4, 8, 3, or 9, 2. We know it can't be the 5, 6 because we've only got a 5 over here. So this 11 either has to be a 7, 4, 8, 3, 9, 2. Now the interesting thing about that is that they're all a high-low combo. So you have 7, 4, 7's a high, 4's the low, 8, 3, 9, 2, etc. So we know that there is a low number here. We also know there's a low number here, which means we have a low number here, the second low number here, third low number here, fourth low number here. And there's only 4 low numbers. 1, 2, 3, 4. I was counting my fingers. 1, 2, 3, 4. Which means that this orange and this one at the end both have to be high numbers. Which makes this and this orange the highs. This pink all the lows. And there we go. Obviously we know a 4 has to be at the end, and we need to have a 4 in this box because there's obviously 9. And we also know a 4 has to be next to the 9, as that's the only thing it is different by 5. And we also know this is a high number. Okay. Other interesting thing, this 11. Anyways, can make 11 with 4 digits. I think it's only 5, 3, 2, 1. 8, 10, 11. Yeah, that makes sense. And we also know 1 can't go there. Classic Sudoku rules. Where to now? Obviously this can't be a high number, so our last 3 lows have to be split across here. For a 2 to be in one of these 4, it means it'd have to be paired with a 9. Already got the 9 there, so that is now our 2. We can take that a step further. If a 2 was in one of these, no, we can't. Yeah, it would be paired with a 9. Yeah, so we also, so we don't know. We obviously know these up to 11. Can't have a 5, which means we can't have a 6 in any of these. So we also know the 6 is there. Which means what do we have left? A 3 and an 8, and a 4 and a 7. The 4 and 7 can't go there, otherwise the 4 would be shown in the same box. No, that's the 4, 7 pair. That's the 38. Pairing. Okay. It's good progress so far. Okay, I guess we'll look at where the 3 goes. Yes, so we know that the 2 and a 3 has to be in those two. We know these two have to be 7 and 8. Yeah, this 7 cannot be next to a 3, as that's only a difference of 4, which means the 7 can't go in the middle. And that means the 8's there. We know that 7 can't go next to a 3. Puts almost finished this, which is really, really nice. Okay. To progress, to move forward from this. Okay, yeah, so well, the 7 now here blocks off 7 from being in these. So we know that there has to be a 7 up here somewhere. Which is quite helpful for absolutely no reason. Great. The next step. We'll look at these 3s. Now this app does come with a nice calculator. So we will make sure to use the best out of this as possible. I could do this all by hand, but like, I cannot be bothered. No, and also this way you get to see it. Okay, well we know these 3 here have to have a 1, a 5, and a 6 in it to complete the row. Oh yeah, so we know this has to be. Yeah, so this can't be the 5 and the 6 because that means this wouldn't work. So we know there is a 1 here, which means we know there's a 1 in this 11, which rules out these 2. Right. Given we also know that there's a 1 in one of these 2, if 2 of these numbers are in the combo, then it wouldn't work. So 1, 2, 8. Yeah, so either the 2 or 8 has to be here, so that doesn't work. The 3 and the 7 also doesn't work for the exact same reason, which means we know now that this is the 1, 4, 6, where this can't be the 1. And this can't be the 4, which now means this is 1, 6, which makes that a 4. If we now know this is a 1, 6, where does the 5 go? Has to go up the top here. Also now this is 1, 6, so the 6 has to be there, which means it can't be there, which means this is the 5 and this is the 6. I feel like we're getting there. We're getting closer to God. Okay, how do we move forward? The next step. We'll actually go to this calculator because we won't need it for a while. Let's get those rules back up. Do these do anything? Okay, we know this isn't a 5 or a 6 because of this 6 down here. Now that's all we've got to go off for the moment. Which isn't much, but we also know it's not the 4 and the 7, so this either has to be a 2, 9 or a 3, 8. Doesn't know anything down for us. at all. Which is, you know, extremely helpful. Sixes. Okay, I guess we can look at this 3 of 11. So we know it can't have a 1, so there's a 1 already in the box. There's also a 6 box. So now we know this has to be a 2, 4, 5. 5 can't go there. Hence the 5 has to be that. We've got a 2, 4 pair. Sweet. Let's get those rules back up. 2 and a 4 in here. Okay. What can we do now? Well, now we know there's 4 in this bottom. This 5 down has to go down here. The same reason the 6 has to be down here. So the 5 in this box has to be here because it can't be in this because it has to be better with the 6 which is already in the box. That removes a 5 from here. Did I add a number? Yeah, I added 4. That doesn't have been there. That means this can't be a 5 either. Which means this has to be the 5, 6 pair. Which makes this either the 2, 9 or the 3, 8. Oh, we also know that can't be the 5, so that has to be the 6. That has to be the 5. But that we get a 1, 3 pair here, which means this cannot be a 3. Or can this, which makes that the 5, that's the 2. That 2 makes that a 4, that makes that a 2. Okay, this 2 obviously here means that this can't be a 2, 9, so that has to be 3, 8, which means this is the 2, 9 pair. Okay. We just cracked. Okay, well we know this isn't the 2, 9, because there's a 2 here, we know this isn't the 5, 6, no this isn't the 3, 8, so this has to be the 4, 7. Oops, no, we know that that's the 7, that's the not 3, that's the 4. And now that can still be a 3, actually, that's because I mistyped. 1, 2, 3, 4, 5, 6, 7, 8. So now I know that has to be a 9. I mean, that 9 just says that has to be 7 or 8, really. And I guess this can be still a 7, 8, or 9 up there. This is 9, does 3 do anything? The 8. That's nice. So the 8 obviously blocks off this, and if this here was an 8, we'll also block off those 2, which means we've got no place left to put an 8, which means that's a 7. Which helps us how? Well, we now know this is 8, 9. We now know there's a 7 here. I think by that same logic, we now know there's an 8 up here as well. The 4 in this box can't go there, so we know this is now actually an 8, 4 pair. What is the last number we are missing from the box? It is a 6. So this is a 7, 6 pair. If I can do my maths correctly. Yeah, this obviously can't be a 6 because this one up here, so 7, 6, this 7's got that 4, 3, 7, oh it's crumbling, 8, 4. Okay, that has helped us. We do get to see what these two are. So they have to have a 1 in that row. We also have to have a 6 in that row. Now we can take this a step forward. We'll go to the 7 in the step further. 7 and 4 in this row. Obviously can't go here. I mean in this right box. So we know this has to be the 7 and 4. And our leftover numbers are the 5 and the 9 for these two in this box. 5 and 9 means that this has to be the 3 to fill out this row. You can also get these pairing over here. We've got a 1, a 2, 3, a 4, a 5, 6 and 7. Actually, so this has to be the 8 number. Cool. We are making heavy progress. Okay, I guess we know that this has to be a 3 and a 4 in here. Because there needs to be a 3 and a 4 in this whisper. Needs to be a 3 and a 4 in this whisper. That can't be a 4, because this one up here. Also, that can't be a 4, because there's a 4 staring right at it. So actually, no, that's the 4. Which means... what's a 4's paired with a 7? Where a 7's looking like? Can't go there, can't go there, can't go there. Oh yeah, and then obviously a 7 can't go now there because that 4 would block it. So that 7 has to find its home in the corner. Okay, so now this pairing gets really interesting because it can't be a 4 or 7. Can't be a 6 and a 5. Can't be a 3 and the 8. So it has to be a 2 and 9. Obviously, since we've got a 9 here, we can get an 8 here and a 9 up here. So now this pairing has to either be a 6-5 or a 3-8. And we have no way of telling. That is fun. Okay. Okay, maybe we can get this pair then actually. Our high numbers are 6, 7 and 8, and we know this has to have a high number, which means it has to be a 9-2 pair. Then this has to be a 1-3. Obviously we know 1 can't go in the box, so that has to be out 3, that has to be a 1, that has to be a 3. Which means this is either 8 or 9. This is now actually an 8 because of this 9, which puts a 9 up here, which puts a 2 in there and a 9 up there. This is really starting to fall for us. This 11. So this 11 actually can't be any of these 3 pairings because then these 3 pairings wouldn't work because otherwise it'd be in the same line. So that actually just be a 4-7. Does that work? Yeah. Yes. But that has to be the 7. That has to be the 4. It's working quite sweetly. Okay, in this box up here, we know that the 2 has to be up there. Sudoku, the 7 has to be here. The 6, does that do anything? Yes, the 6 has to be here. So which makes that a 6-7 pairing. Now, okay, well, 2 has to be paired with another number in the box. It's going to be a 1. Okay, well that creates a 3-8 pair here because of technical reasons. Yeah, because that row this is so close to just falling apart. So whatever this, we know both a 2 and a 9 can't go here, so the other 2 and a 9 has to be over here. At least Wisconsin still hasn't provided us anything, because we both have a high and a low. Because a 7 can work with a 2, can't it? And a 9 can work with a 4. Oh, this row now doesn't have a 1 in it, does it? Correct. Which makes this a pairing now, as the last 2 in that box, 5 and 4. No, that can't be a 4 because of this, so that makes it... Actually, no. We've already got a 4 in the box. What am I doing? Because there's a 4 right here, so it can't be a 5 and a 4. Has to be a 5 and 1, 2, 3, 4, 5, 6, 7. No 8s. There we go. 5 and 8. Thank God I caught that before it all went downhill. Honestly, that can still be a 5, can't it? Why can't that be a 5? Oh, because I accidentally typed a 5 in here, right. Alright. The next step. The 1. We know the 1 can't go there, can't go there. Obviously can't go in the 11 because 1 plus 10. Yeah, you get your 11. Is that 1 there? Just double checking. The 6 can't go there or there. Yeah, so that's the 6 here. To make this 11, we need the 5 to go in here. Which makes this, the only number not in the box is a 3. Which puts us at 8 up here, 3 here, 8 in here. So how did this work at 5? Because we placed a 5 in the bottom, 8 here, 5 here. We'll just trust it 1 and 6. Those last 2 squares. Okay, well we do only need 1 number to figure out this. These 2 here. This row. 1, 2, 3, 4, 5. We need a 6. No, don't. What do we need? We need a 3. And this one, we need a 1. Guess that top left is figured out. 2 and a 9 down here means that this has to be 1, 2, 3, 4, 5, 6, 7, 8. Which means that we can see that that's a 3 now, that's an 8 now. This better actually work. Okay, so now we know these last numbers are a 2, a 9, and a 3. 2, 9, and 3, and we know a 3 can't go there, so that has to be 3. Makes that a 2, 9. Cool, so I've got most of the board figured out. What can I rule out? Ah, 2, 9 means that there can't be a 2 up here, so that has to be the, what has to be the 1? That has to be the 2. I think this will just solve itself now. That has to be 6, that has to be a 1, that has to be 7. Here's 6, that has to be a not a 3, a 4, that has to be a 7. The 5 there. I could have figured that out way earlier, couldn't I? Because that 5's been sitting there for since the beginning. Since the beginning. I could have figured out that so much longer ago. That probably would have been done 8 minutes ago. Really? Whatever. That's a 9 now. That's a 5. Okay. Ah, this is where this whisker comes in handy. Because if this whisker wasn't here, we would be guessing these last. That's so sick. So obviously whisker has to be different by 5, which makes that the 9, that the 2, that by 9, that the 2, that the 9, that finally the 2. 30 seconds, not 30 seconds, geez, that'd be genius. 30 minutes. It's pretty good. I didn't really struggle that much at all, honestly. It's kind of surprising. Everything just kind of came to me. That thing at the end, that 5, I should be able to pick that out so much earlier. That one whisker, which seemed pretty much irrelevant for the whole game, helped us place the last 6 digits. That's kind of cool. Yep. It's back as requested. And we will see if we do make a third. But that was fun. So I will see the two of you and anyone else that watches sometime later. Peace.